Last little thing we got to add is distance on the coordinate plane. With the distance, that's also going to include some shapes, finding some area or perimeter, okay? Finding distance, so that's distance. So finding distance in a coordinate plane is just like we did finding it on a number line or with our negative numbers. Distance is always what? Positive, yeah. Distance is always positive. So it doesn't matter for this if you go from a positive to a negative. It's still going to be a positive number. Distance can be found by plotting the ordered pairs and counting the squares from one point to the next. So that's one way you can do it. You can plot the points on a graph and count how many squares are in between them. To me, that takes more time. You'll have graph paper on the test and stuff, but it's going to take a little bit more time to do it that way. You gotta graph them, count all the squares, that sort of thing. So the other thing you can do is what you want to do is eliminate the common number in an ordered pair. And then you find the distance between the two remaining numbers. To me, this is much quicker than taking the time to find where each point is and count up the squares. All right, so we're going to do a couple, or I'll show you a couple, just, it's not that bad. So this is there towards the top of page 65. If we look at point A and point B, we see a common number, right? In this case, it's that 1 for the x value. So what we're going to do is we're going to ignore that 1. We're going to ignore the x value. So we are just going from 3 to 7. How far is it to go from 3 to 7? 4. You see how that works? Not so bad, right? All right, C and D for the next one. This time the common number is the 2. It's the y value. All right, so we're not using the y value. We're going from -1 to -6. How far is it from -1 to -6? 5. Basically, if these signs are the same, like they're on the same side of 0, both positive or both negative, you're kind of subtracting those two numbers from each other. All right, go ahead and try E and F and G and H. All right, EF, Noah, what'd you get?
8 for E and yeah, 8 for
No? Levi?
7.
7. We're going for, we ignore the 7s. So we're going from 2 to -5. If you're going from my opposite sides of 0, positive to negative, negative to positive, either way, you basically end up adding them because we're going from 2 to 0, that's 2, and then 0 to -5 is 5, so you gotta go that way. GH, Ben? No? 9. If you end up counting, if you were to graph them and try to count the squares in between, when you count, you do not count the number you start on. All right? If I say to count to 3, everybody goes 1, 2, 3, right? We don't go 0, 1, 2, 3. All right, so the same idea would apply if you graph those points and try to count the squares. You don't count right where you start. But from -4 to +5, from -4 to 0 is 4, 0 to 5 is 5, 9. Any questions on that? All right, turn way ahead to page 167. All right, so this says polygons in the coordinate plane. What's a polygon, first off? Yeah, shape with 3 or more sides. I mean, to make a shape, you have to have at least 3. All right, so the order pairs can be used as vertices of polygons. Anybody know what a vertex is? Or a vertice? Yeah, it's the corner. It's the corner of the shapes, okay? So if we plot these points or get the ordered pairs, they're the corners of the shape, okay? To draw the polygon, you would plot the points in order and connect the dots. And then each unit, each square, counts as 1. So you can plot them and count. You could also, do like we did before and find the distance between the points. Some shapes, it's necessary to plot them though for this, okay? Sometimes you might be asked to find a missing point, find the perimeter, find the area. If you're finding the perimeter, how do you find perimeter? Yeah, to find perimeter, it's adding up all the sides. For y'all, it's pretty much going to be rectangles for the perimeter problems, okay? Triangles, even if it's a right triangle, have to have at least one diagonal side. So if you had to find the perimeter on a triangle, they'd have to give you that other side, okay? For a rectangle or a square, they don't have to give you any of the sides. You should be able to figure out like straight edges for this. Diagonal sides you'll have to figure out in 8th grade. Area then is the measure of the inside of the polygon. How do we find area of squares, rectangles, and parallelograms? Length times width, base times height, same idea. You get 2 numbers, you multiply them together. Parallelograms will be a little bit different. We'll do an example of one of those in just a second. Rectangles and squares, pretty easy. How do you find area of a triangle? Base times height divided by 2. Could see triangles for area. Probably will see triangles for area. All right, trapezoid. All right, trapezoid is the weird looking one. You have to add the 2 bases. There's a reason they're in parentheses. That has to get done first, okay? So if you're ever doing it without a calculator, add them first. Even if you're doing it with a calculator, add them, hit enter, and then do the other stuff. The order on that doesn't matter. You could divide by 2 after you add them and then multiply by height, or you can multiply by height and then divide by 2. Okay? Any questions on those? Been a long while since we did area. That was like August, September time. All right, so let's see at least a couple. If they give you a picture, we have to count the squares. You can see this in your book. They kind of already show you how this works. But just to kind of demonstrate, you need a flat side. It either needs to be straight vertical or straight horizontal. You cannot use diagonal sides on these shapes, okay? Everybody clear on that? So what we have a straight side, straight side. Don't really matter which one we're using to count. We just got to count on one of them. So how many squares are those? 3. So we got 3 here. What we need to do then is connect those 2 straight lines with a line that is perpendicular to them, like goes straight in between. These are straight vertical. Our other line needs to be straight horizontal, okay? So basically like that. Everybody follow? All right, how many squares would that be? 8. So what's the area of this parallelogram? 24, 3 times 8. Okay? Any questions on that? All right, triangle. Little bit trickier. We still need a flat side. Okay? We have a flat side at the top there, that horizontal line. So we're going to use that. How many squares is that? 7. What that flat line is going to be our base. Okay? How do we find the height? We got to go straight from the base to the point opposite. All right, so the point's right here. If we have a straight line, that's going right there. Okay, how many squares is that? 4. It's not difficult. It's sometimes a little tougher to count when you have like those little partial squares, like we're getting right here kind of thing. It still counts as a full square even though it's, got just that little corner on that one. All right, so now we find the area. Base times height divided by 2. And we get, 14. 7 times 4, 28. 28 divided by 2, 14. Okay? All right, turn to 168. All right, I'm going to show you a couple things. These both in your books, they're asking you the name of the polygon. You could also have to find area or perimeter based on the coordinates, okay? So 2 things we could do. One way, I'm just going to find the distance, okay? So what I highlighted there in red, what's the distance there? 3. Purple, what's the distance there? 3 again. You'll notice each time it overlaps, right? All right, blue ones, 3 again. Whoops, not what I wanted to write with. And then D and A in green, what's that? 3. Hey, if all 4 of them are the same, what shape we probably got? Square, yeah. Okay. Other way you could do this, again, you'll have graph paper. We can graph these. 2, 4, right there. 2, 7, right there. 5, 7, right there. 5, 4, right there. And you can see, even before I connect the dots, we got a square. Okay? Any questions on that one? All right, now the next one's a little trickier. Here's why. If we look at it the same way I started off with the first one, what's the distance there? 6. What's the distance there? You know what that's called? 8th grade math. You'll have to do the Pythagorean theorem. What that means is you have a diagonal line there, okay? As 6th graders, y'all don't have to do that. Y'all can't do that. But you do have a diagonal line. So how do you figure out what shape this is? No, you got to graph it. All right, so if it's asking you what shape and it works out like that where you have a diagonal side where you can't figure it out by eliminating, you got to graph it. So go ahead, graph that. Figure out what shape that is. If they're all straight sides, like that first example was, all you have to do is find the distance. If they're all the same, it's a square. If they alternate, like if it would have been like 3, 5, 3, 5, that makes it a rectangle. Once you have a diagonal side, you got something different. There's 4 points, so it's got to be something not a triangle. That leaves you basically with either a trapezoid or a parallelogram for your 6th grade shapes. Who can tell me what it is? Shane? Trapezoid. -3, +4. Got a dot about there. +3, +4. Dot there. 6, -5. Dot there. -6, -5. I don't know why it changed color, but dot there. We connect our dots. You can see that's a trapezoid. Okay? Any questions?